It's 2 minutes past, so let's get started. Welcome everybody to the November 18th SIG Multicluster call. Today on the scrub, we have a number of items, well, including one which is probably more of a topic. And Scott, I hope you don't mind, I just added your kubectl MC plugin demo as a topic.
Yeah, no problem.
So I'm still having issues with Zoom and screen sharing, so I won't share my screen, otherwise I'll just disappear for the rest of the call. So the first item in the scrub is the KEP 5339 patch to add an additional cluster-specific auth info field. So this has had a bunch of review comments, and perhaps more significantly, well, what turned out not to be a conflict with another PR, 5643, and so we've agreed to merge that one first, and it seemed okay to me, so I've approved it. So it's passed its tests, and all it needs is another LGTM, and then 5559 can be rebased on top of that. Does anyone have any comments on these? All right, I'll take silence as a negative. So then the next scrub entry is survey data, but I guess we can revisit that in the topics. And then then in the scrub still, there's the KEP 1645 enhancement to add traffic distribution and internal traffic policies fields. And so this one has been approved by me. And all it needs is an LGTM. So anybody in the SIG who is reasonably familiar with KEP 1645, please feel free to look at it, and if it seems satisfactory to you, add your LGTM so they can get in, along with the code change PR on MCS API. And then, right, placement decision API is in the same situation, I think. All right, no, it needs to be approved as well. Yeah, we didn't get a chance to go over that again at KubeCon, so I'll add it to my to-do list for this week. And that's it for the scrub entries, I think. And yeah, I see your thumbs up, Mike. So Priya, do you want to discuss the survey?
Yes, yeah, sure. I can discuss the survey. So do I need to go through the slides, or like is that only the information regarding the any survey details?
Well, let's see what people think. I mean, there are quite a few folks in the call who weren't at KubeCon, and the video is not out yet, so at least I don't think it is. So I think it would be good to have a presentation with the slides in the call.
Okay, yeah,
If you don't
sure.
mind.
Yeah, sure. Give me a second. I'm just pulling up my survey.
Yeah.
Okay, I'm gonna share my screen.
Yes, please.
So yeah, the survey is about building the multi-cluster management and monitoring solution user research survey report. So our main goal is to make complex systems easy to use and turn difficult operations into simple and human friendly for our engineers. In our survey, we designed the survey for our engineers who are working with multi-clusters, and we focused problem areas on environment, tooling, observability, troubleshooting, automation, and collaboration. In our survey, we included qualitative and quantitative questions to learn about how engineers are working, what they are using, and why they are making certain choices. We sent this survey to Kubernetes SIG community channels, and we did receive responses from 150 engineers. To work on the research data analysis, we used text analyzer for written responses and Python for numerical data, which help us on identifying the patterns between demographics, tools, and challenges. And our respondents represent the diverse backgrounds, such as 38% are platform engineers, 26% are DevOps engineers, 10% are site reliability engineers, and remaining cloud and software developers. These represent that our survey reached to different people. Now let's move on to key insights. We start with the qualitative highlights. We ask our engineers why their organizations run multi-clusters, and we identified 5 common patterns. The first one is infrastructure provider engineers, and the organizations run their clusters on cloud, on premises, and edge locations for flexible deployments and independence on vendor lock-in. The second one is isolation. So teams are separating their workload and environment for better security and easier management. Third, business unit. Each team gets their own cluster, which gives them a ownership and easy compliance. Fourth one is region. Engineers are deploy their clusters across different geographical locations to achieve high performance, geo redundancy, and better service availability. And the final fifth one and most common pattern is environment separation. Organizations always separate development, staging, and production environment, which help developers test the deployment safely without breaking the live system. Now let's move on to another slide which represent quantitative highlights. Which represent that engineers are facing key challenges in managing multi-cluster systems. Our user research identified 4 major key challenge areas, such as 51% of engineers are struggling with workload management, 39% of engineers are struggling with observability and monitoring, 25% of engineers are struggling with operational complexity, and 10% of time management. Engineers are daily struggling with workload management, such as stateful workloads, configurations, upgrades, data distribution, and multi-cluster operations. And the next one is engineers are facing struggles on to understand what's happening across the cluster is very challenging because the data is spread across multiple tools. However, and also they are complaining about network complexity. Engineers are following the structured on-call process while they are having critical alerts. However, the alert looks, but our research identified that every alert is unique to them because however, the alert might looks familiar, but the cause and impact is always different because the situational awareness, if engineers know how, what, and why the impact is, so they can act with confidently. And next, operational complexity. Engineers reported challenges on environment setup, repeated tasks, and automation failover scenarios, which always lead them to a manual intervention, and also limited team knowledge. Sorry. And also engineers are spending a lot of time on slow deployments and repeated setups. So these are the key challenges clearly represent that engineers are having a lot of challenges while working with multi-clusters. Our research also identified that we ask engineers what do they want in their future of multi-cluster operations. Our research identified three common patterns such as AI and automation on operations that can handle the routine task, so the engineers can focus on high priority tasks. Flexible architecture, so engineers that allows different performance and deployments and cost needs. And final one is simplified UX with easy to use dashboards and simplified workloads and clean documentation that helps engineers every confidently work with confidently. And also our research identified unique responses such as dashboard as a code for functionality and specialized hardware requirements for multi-cluster operations. Now let's move on to quantitative highlights, which represent that 44% of engineers are managing 1 to 10 clusters per month. 32% of engineers are managing 11 to 50 clusters per month. And 22% of engineers are managing more than 50 clusters per month. Let's move on to another pie chart, which represent that engineers deploy their clusters across multiple infrastructure providers. 49% of engineers are deploying their clusters on single cloud providers. 22% of engineers are deploying their clusters on multi-cloud, and 21% on on-premises data center, and 7.2 on hybrid locations. Now let's move on to another quantitative highlights, which represent that 44% of engineers are deploying using their multi-tenant cluster of model. 21% are single tenant model, and 33.5% a mix of both, and 0.6% of engineers mentioned not sure what to say. And our final pie chart, which represent that automated responses for cross cluster issues. 61.2% of engineers mentioned automated failover. 23% of engineers mentioned no automated action. 12.5% of engineers mentioned auto-scaling based on workload health, and 3.1% of engineers mentioned policy-based workload redistribution. Now let's move on to another quantitative highlights, which represent that majority of the engineers are using Argo CD, custom controllers, Rancher, Caverno, and Thanos for their multi-cluster operations. And also we identified that engineers are not using any tools to operate their multi-clusters in their multi-cluster operations. One of the platform engineer who manages 50 plus clusters says that multi-cluster isn't just a scaling up choice, it's a strategic evolution towards flexibility, innovation, and resilience. From the user research, from the data analysis, we identified 5 user research areas such as documentation gaps, centralized monitoring, AI-driven automation, operational complexity, and developer UX. Let's see how our recommendations can improve these user research areas. We recommend review the multi-cluster project materials and identify what's missing and outdated, and then create a practical guide with real examples and work with the SIG community to build a field-tested documentation for engineers' daily work. We recommend identify the current systems and tools and gaps and overlapping, and create a centralized observability system with the common standards of log metrics, data storage, network visibility, AI connected alerts, and a role-based dashboard. Next, we recommend AI driven automation can help engineers routine tasks. And the fourth one is operational complexity. We recommend we recommend organizations can provide a practical hands-on experience to the engineers on multi-cluster operations. Also, make reliable automation, and by sharing the knowledge through playbooks and peer learning can close the skill gap. We recommend understand and learn about the developers existing practice tools and methods, and identify the what's slowing them down, and by using those studies, create a developer-friendly solution for multi-cluster operations. One of the software developers says that make it easy. This user research is completely highlight that future of multi-cluster management is the combination of technical excellence plus human-centered design. Yeah. Thank you.
Yeah, thanks. And Ryan has a question.
Yes, yeah, Ryan.
Thank you. I think again, the survey is very useful. It's very important for us to understand as a community to understand our use cases, especially we're defining a lot of APIs. Right? So that is definitely something we don't want to define things that nobody want to use. So,
I'm gonna stop sharing. Okay.
Yeah, that's fine. Thanks. Any other comments on the survey before we move on to the next topic? All right, some
Not
people showing their
necessarily a
appreciation.
comment. Oh, yeah, sorry, a very small comment.
Go ahead.
I noticed that there's no things like service mesh wasn't strictly speaking mentioned, but the network complexity was mentioned, and I do think that I do hear that from the community from time to time, where people have trouble visualizing or abstracting or putting it in their mind how the network works, how things communicate between components. And yeah, I suppose that if it's hard for them for user administrators to reason about it, it's also going to be hard for them to put anything down in the comments or in the survey. So it's interesting to see that at least it's surfaced via the network complexity, but it's not surfaced in any other way. Yeah, I think that is also a very useful insight from this.
Yeah, Ryan.
so I think Zoom just kicked me out. John, you want to finish?
Yeah, I was finished. I got interrupted by our future cloud engineer here. So yeah.
Go ahead. You finish what you were talking about.
Yeah, I finished. Yeah,
Oh, you
the
finished?
gist of it was just the abstraction of networking, or the mental model of networking or service meshing, that it is still an issue, especially a couple of, I think not last week, but the week before that, there was some sort of, I think in one of the podcasts, I think the Kubernetes podcast from Google, the idea that the service mesh would eat the world, and then it didn't happen. I don't think it's because there was no value in it. It's because even though it did greatly simplify some common scenarios, it was still too difficult for people to grasp. And this survey essentially shows the same thing. Yeah, that was my comment. And now I'm finished.
Yeah, sorry. Yeah, also, hopefully this time Zoom didn't kick me out. So I was thinking two things. One is there are a few things I have, I'm not sure, and my team also was very curious about exactly how we process the data. So after terminology, things like that, sometimes it's not exactly clear on what that's. I mean, for example, there's an automatic failover part, and we are not entirely sure what does that mean. So two things. One is I actually talked to Jeremy during that presentation. Is I think there needs to be a way for the community, the SIG, to be able to actually see the raw data. Maybe we need to anonymize, make them anonymous, but I don't know exactly what is the process. So I want to ask here, how can we get this data actually be not just a PPT? We would like to actually analyze the data. Also, secondly, I think we are still collecting feedbacks or collecting a response, because we share that link in our talk, and I think we could keep on this. But there are a few things I think that we could tweak it a little bit. For example, again, there's automated failover. Probably we can make. I don't know exactly what was in the survey, so maybe we could make it clear what does automate failover mean. Just to give a little bit detail on why we are a little bit confused. I can there are several things you can call them automated failover. For one case is someone, and today is actually a very good day, right? In the sense that good example that something happened. So uh, uh, so you realize that one region is actually down, right? That's a good example. Exactly, we know that some region is down. So if you have a tool that can one click move your traffic from one region to another region, is that considered as automated failover? Or you need something like you have a monitoring system. You detected that some traffic is either have high latencies, either have large 400, 500 errors, or success rate drops down to say 30%, then the tooling automatic start to shifting the traffic. Right? That which one is automatic? Are they? I think we can argue that we can argue the first case is also considered automated because you don't need to do anything, just one click move. I'm not 100% sure what's the definition. So just give an example. Maybe it'd be great to look through allow the community actually to look through the survey and improve it. So it's not that just a few people conduct survey and present it twice a year or something. Yes, that's it.
Yeah, well, we can ask the survey organizers if it would be possible to have the raw data.
So
I'll discuss that with them.
okay.
Yeah.
Okay.
All right. If there's nothing else on this survey, Scott, it's your turn.
All right, thank you. Let me share my screen here. Although I'm not. Can everybody see my screen? Or is it not working yet?
Not yet, no.
Hang on, I might have to rejoin. Give me 5 seconds. Let's try this again. Okay, now can you see it?
Yeah, we can see a
Okay.
terminal window. Yeah.
Okay, yeah, so for just did a quick POC demo here. So for context, this is around the user experience with multi-cluster scenarios. So that's one of the things that we struggle with in our organization is kind of once we introduce this, if you have lots of developer teams and how do you give them a similar user experience that they're used to with kubectl? So I did a quick POC here, and the thought is, perhaps we can have some sort of a standardized, vendor agnostic kubectl plugin or something that using cluster profile can enable, the experience that developers are used to. So I did a quick demo for that. So this is again just a quick POC. I think so upfront, the experience would be you just run a setup command. It'll go and it uses cluster profile. So actually, before I do this, so I've got 3 kind clusters here, and I'm using OCM for this, but it's not. There's nothing here that's vendor specific. And so I have those set up here. So I've got 2 spoke clusters, and I have a hub. So which I'm currently pointed at the hub cluster. And so then I have the cluster profile syncing turned on from OCM. So it'll sync OCM's managed clusters to cluster profiles. So I've got 2 of those cluster profiles here. So the experience would be if I just run this, and again, this is very EOCE, so I just have a quick like mapping file. So it uses cluster profile and discovers them and then makes a little map file. And so I have that set up now. So the user experience should be very similar to what I'm used to. So like on the hub cluster, I have an Nginx deployment in the test namespace. So normally, like as a developer, if I'm not used to, if this wasn't there, I'd have to go use specific context and go get each information from the spokes directly. But if I use the plugin, I can go see the pods, and it aggregates the results back to me. So this is kind of the similar thing that I would expect if I'm just using regular kubectl. I can also get namespaces everywhere. Oops. And it'll list, things like that are available. I can get services. I can limit it to a specific cluster if I want, or that sort of thing. So yeah, it just gives you kind of the thing that you're used to. I can also apply things. So if I have so I added some basic write functionality. And again, I think from a discovery standpoint for like cloud-based things, I would probably look at using the access provider and go just dynamically, get the EKS or GKE or whichever, cloud providers for these. But so if I wanted to apply these, I could do the same thing. So I create a namespace, a config map, and a pod, which will create those. Then I can go ahead and get I did MC plugin test. Helps if I add the. So I've got the pods there. Got the config map. So I can do that stuff. I can also delete those. Or I can actually get so if I wanted to say, like as a developer, I knew I wanted to get rid of that. So I did that. I can also get if I want to get one, like I'll like if let's say I have a name of a pod I want to delete from, and I don't know which cluster it's on or something. Let's say I want to delete this pod name for whatever reason. This is a problematic thing. I just want to delete it. So I can do that, and it'll go multiplex. And as long as it works on one of them, then it'll say it worked. So yeah, I mean that's the basic user experience that I'm kind of hoping to enable with this. And then I can delete the rest as well. So yeah, that's the basic demo. It's real quick and dirty, but just kind of hoping to solicit feedback and see if this is something that the SIG would find useful as a UX. I think if possible, the intention would be to, donate this and maybe see if the SIG would be interested in hosting a code for it and keep it as, vendor agnostic and just API based as possible.
Yeah, I think definitely super useful tools here. And I think that we have a cluster profile repo. I think that belongs to that repo. So that we have the server side and the client side together. That gives the community a very good end-to-end of complete experience, not just the server side of you. You can do the Kubicado thing. This looks very powerful. Super excited about this.
Yeah. So just to be clear, right? For now, well, the YAML file that you showed being created at the start, that's because you rely on having local contexts to point to each cluster. Is that correct?
Yeah, in the POC,
Yeah.
it relies on local context. I think, if we did this for real, likely we'd want to use the access provider stuff that was just added to cluster profile, and that would make sense
Yeah.
for each cloud provider. We could just go dynamically, do whatever exact plug in there and pull those dynamically. I think would make the most sense. But we could also, it could keep the local mapping for if you had on-prem clusters or something like that.
Yeah. Yeah. And can it run any kubectl command on each cluster, or is there have you coded get, delete, and so on?
It's the code is kind of hybrid. It's so for the get, like the read operations, those are specific, resource specific. I'm not like shelling out to kubectl for it, but most things are basically supported like the get all. It implemented a similar like a pseudo resource, and it goes and it uses the RESTful discovery API to get the GVRs and stuff. So it's most things you can get read only that way, and it's done that way. For the write operations, I'm currently just shelling out to kubectl to make that simpler because it's going to do it in, separately. I didn't want to have to re-implement that, and I'd like to try to not fork kubectl if at all possible, and have maintenance of that. But so once if the SIG's open to this, then I'm happy to share the code and take feedback on that and see which, if there's any feedback on what it looks like. But I was trying to keep read operations, streamlined. But then the reason for that is like the aggregation, right? Like I didn't want to shell out to something because I needed to aggregate all those in a view that you would want to have normally.
Yeah. Yes, very nice. Seems very useful. Thanks. Yeah, purely from an E2E, it would already be super useful. Yeah. So I reckon, well, we'd have so the way this usually works, I think, well, the way this works, not usually, just in all cases, the SIG has to have a vote over email, and then we can figure out all the legalities and where it ends up. But I at least would be super interested in hosting this in the SIG.
Great. Sounds good.
Yeah.
Thank you.
Should we or you, I don't know, talk to the kubectl folks also? Maybe they want it by default or something, I don't know.
Wait, is there a place that all the plugins are hosted?
Yeah, so there's just to address Arthur's question, yeah, it might be worth talking to the kubectl folks. Given that this relies on SIG-MC APIs that aren't part of core kube, that might be an issue. But yeah, it doesn't hurt to ask. And
so wait, it's like a crew plugin right now? I didn't.
Yeah, it would be like a crew plugin. Yeah. So
okay.
Yeah. So for those who don't know, Crew KREW is a kubectl plugin manager, and it has so you can use it to install and remove plugins, and it has a sort of hub type thing, a catalog of plugins, so you can distribute plugins on Crew, which means that once they're installed, they can get updated and so on. Yeah, thanks for posting the link. So that would be one way of getting it. So the advantage of hosting it ourselves is that we could make changes without having to get PRs approved by kubectl, which might be interesting, at least initially.
Well, yeah, if it's a crew plugin, probably it can be super helpful. And in case, well, it sounds like a small possibility, but in case they really want it by default, it would be upstream the crew plugin into kubectl, I guess, something like that.
It'd be upstream the Crew plugin? What do you mean?
Like merge back the crew plugin in the core code or something like that. But I don't. Yeah, reflecting it back, I don't think that they would want it, because well, crew plugin is already super easy to install and all of that, so should be okay.
Yeah. Okay. And Scott, is there a publicly available repo where the plugins could be made available until we figure out where it should go?
Not yet, but there can be. I can.
Right.
I'll update the Slack with the repo once I have that.
Okay, thanks. Yeah, because usually the way it works is let me see. Yeah, so for something like this, you'd have an existing repo, and then once it gets approved into the SIG and all the legalities are sorted out, the repo would be migrated into wherever it ends up.
Yeah,
So
I
it
have a
hasn't-
repo. I just
and-
haven't published it, so
yeah.
I'll publish
Yeah.
it and then let you know.
Right. Thanks. And that was the end of the topics. So unless anybody else has anything to bring up, we can end the call there. And I'll see some of you on Tuesday and some of you next week. Until then, well, have a good week.
Thank you.
Thanks.
you.
See you.
Bye.
Thank you.